Welcome to section 2.4. We're talking about complex numbers. We're going to be working with I today, which we did in Algebra 2, but we're going to come back. I want to start first with the intro, which reviews the big idea from section 2.3. So I'm going to start with, given a couple of solutions or zeros, don't forget solutions are the same thing as zeros, I give you a polynomial, can you find the rest of the zeros? Well, taking a look at degree, I should have 4 zeros because my degree is 4. So I have 2, I need to find the 2 remaining. What we're going to do is synthetic divide. So I'm going to start with the 5 and synthetic divide with my coefficients. 1, -3, -9, -3, and -10. So I'm going to synthetic divide. Because they tell me that 5 is a solution, my remainder should be 0. And so we just have to make sure we get there. First step, drop down the 1. 1 times 5 is 5. When you add it to -3, you get 2. 2 times 5 is 10. When you add it to -9, you get 1. 1 times 5 is 5. When you add it to -3, you get 2. 2 times 5 is 10. When you add it to -10, yes, we do in fact get 0. And so we're left with this polynomial. We are going to synthetic divide one more time with x is -2. And I'm just going to attach it to here because it's the easiest. Remember, we don't need this remainder of 0 anymore. So we drop down the 1. 1 times -2 is -2. When you add it to 2, you get 0. 0 times -2 is 0. When you add it to 1, you get 1. 1 times -2 is -2. When you add it to 2, you get 0. And this should happen because, again, they told us that x equals -2 is a solution. So I'm left with a polynomial. And we said this is our remainder, our number, our x squared. And so I'm left with this polynomial, x squared plus 1. And my goal is to find the zeros, so I'm going to set it equal to 0. I cannot factor this because it's not a difference, it's a sum, and we don't do sums of squares. So I'm just going to go through and solve. I'm going to subtract 1 on both sides. X squared is -1. When I square root both sides, I get 2 answers, a positive and a negative. And let's go back to a definition we should know. The definition for the square root of -1 is I. Therefore, my 4 zeros are 5, -2, I have a positive I, and I have a negative I. Okay, and that's going back to the idea of a complex number. So let's go to a couple of definitions a second. If A and B are real numbers, then A plus BI is what we call a complex number. And I'm going to shorthand this a second. It is said to be in standard form, and standard form is huge. Okay, so important. It has to be A plus BI form, which is called standard form. Okay. If B is 0, then this BI is gone, and you just get A. A is called just the real number. Okay? If the B is not equal to 0, but maybe the A is gone, then it's called an imaginary number. Okay? So if B is not 0, if it has this BI portion, it's called an imaginary. If you just get this form BI, if your A is gone, we modify that idea of an imaginary number and we call it a pure imaginary. And all it means is that the real part is gone, and so all you have left is the imaginary part. Okay? Now, this pattern here, you will want to kind of keep in mind on this pattern. Not supposed to say pattern, I apologize. Okay, take a look. I is the square root of -1, but again, we're not going to say this, we're just going to say I. Now, I squared is the same thing as squaring this quantity. And if I square, it eliminates the square root. You're left with -1. This you're going to use very often. I cubed is basically taking I squared with another I. And I'm going to split this up so you can kind of see this pattern. I squared is -1. -1 times I is just a -I. And I to the 4th is like an I squared times an I squared. -1 times -1 is a +1. And these 4 will continue to rotate around and around. So 5 is basically I to the 4th times another I. Well, I to the 4th is 1. 1 times I is just I. And I to the 6th is like an I to the 4th and an I squared. I to the 4th is 1. I squared is -1, so you get -1. And you'll start to see how these connect and how these connect. Take a guess on what the next one will do. This will be a -I. And the last one will end up being 1. Okay, and let me give you an example of something that's coming up. They might ask you what is I to the 12th power. And what I do is take this 12 and I take 12 and divide it by 4 because the pattern repeats every 4. And you end up getting a 3. And so what you do is you look then at the third number, which is a -I. My answer is -I. So if you end up with a 1, you look at, and then your answer would be I. If you end up with I'm sorry, let me change this. It's a whole number, so there's no remainder. And so you end up getting 1. It's the last one. You get a whole number. If you end up getting 0.25 as a decimal answer, somewhere in your answer it says 0.25, it'll be I. If you get 0.5, it'll be a -1. If you get 0.75, it'll be a -I. And if you get a 1, a whole number, then it ends up being 1. So I apologize for that little mix up there. But this is the idea, and I just put this on because I believe there's one like this on your homework. It gives you a huge number, but you're looking at your remainder. If you don't have a remainder, you know, if you get a 0.0, there's no remainder, then it's just 1. If you get 0.25, it's I. 0.5 is -1. 0.75 is -I. And so that's kind of the idea going through. Okay, we're going to work on a couple of questions dealing with complex numbers and how to work with these. You did these in Algebra 2. I just want to go through and review. Okay, so we're going to add A, which is 5 plus 8I, to B, which is 3 minus 10I. So I'm going to stick these in parentheses, although it's not necessary. I'm sorry, 5. Let's just erase this. Okay, A is 5 plus 8I, plus B is 3 minus 10I. When we look at complex numbers, we add the like terms. So 5 plus 3 makes 8. 8I and a -10I is -2I. And please make sure your answers are in standard form, which means the I part comes second. If I go to subtract them in B, 5 plus 8I minus 3 minus 10I. Easiest way is to distribute the negative. So 5 plus 8I minus 3 plus 10I. So this turns to a negative, this turns to a positive. I again add my like terms. 5 and -3 makes 2. 8I and 10I makes 18I. You will have questions. Actually, these 4 will be on the quiz. Okay, so you will have to do one of each: add, subtract, multiply, and divide. And so far, I think it's probably okay. C is when we start getting a little bit more in depth. I'm going to multiply these. So 5 plus 8i times 3 minus 10i. And if you look, you have a binomial and a binomial, which means FOIL. So 5 times 3 is 15. 5 times negative 10 is negative 50i. 8i times 3 is 24i. And 8 times negative 10i is negative 80i squared. You cannot leave an I squared answer. I squared is exactly the same thing as negative 1. So negative 80 times negative 1 is really a positive 80. So once you've changed your I squareds, then what we're going to do is combine like terms. 15 and 80 makes 95. And a negative 50i plus 24i is negative 26i. You will never have an answer with an I squared in it because please remember I squared is negative 1. Okay. Last one here is division. So we're going to take 5 plus 8i divided by 3 minus 10i. And like square roots, we never leave an I in the denominator. And so we're going to multiply by what we call a complex conjugate. And the complex conjugate changes the value of b to its opposite. So the conjugate of a plus bi is a minus bi. So in this case, you always look at the denominator. I have 3 minus 10i. So my conjugate that I'm going to multiply by is 3 plus 10i. And you only change the I part. Please keep that in mind. You only change the I part. What you'll notice then is we have a binomial times a binomial on top and bottom. So we're going to FOIL. 3 times 5 is 15. 5 times 10i is 50i. 8i times 3 is 24i, and 8i times 10i is 80i squared, and I'm going to change that in a minute, but I'm going to do the bottom first. 3 times 3 is 9, 3 times 10i is 30i, negative 10i times 3 is a negative 30i, and negative 10i times 10i is negative 100i squared. Okay, now I'm going to do some work, and I'm going to change my color a minute so we can kind of see the work we're doing. If you notice in the bottom, the 30i and the negative 30i will cancel out. They're conjugates. You don't want an I part left in a denominator, and so they will cancel out. On top, 80i squared is the same thing as negative 80, because I squared is negative 1. Negative 1 times 80 is negative 80. Negative 100i squared is the same thing as positive 100. And so now I'm going to do some simplification. In the numerator, 15 and negative 80 is negative 65. 50i and 24i is plus 74i, all over 9 and 100 is 109. And we want our answers in a plus bi form, which means I need to split this up in my two parts. If I can reduce fractions, you should reduce. In this case, they don't. But negative 65 over 109 plus 74 over 109i. This is the answer, not the one above. You need them separated so you have an A plus BI form. So please keep that in mind. So you will have to, on the quiz, again, do all four: add, subtract, multiply, and divide. What we're going to do is flip the page and look at a couple of other things that we do with complex numbers. And then after that, you'll get to work a little bit on your homework. So take a look. Here's what we're going to do. I'm going to break, anytime I see a negative underneath my square root, I'm going to pull out an I. So this is I square roots of 12, and I see a negative under this square root, so this is I square roots of 3. And anytime you see a negative, you want to pull that out. Okay? Now what I'm going to do is multiply I times I, which is I squared, and I can multiply my square roots. 12 times 3 is the square root of 36. Well, let's take a look. Can we simplify this? Well, sure. The square root of 36 is 6, and I squared is negative 1, so my final answer here is negative 6. In part B, I can't add or subtract square roots until they are exactly the same square root. So what we're going to do is do some breaking up. I'm going to pull this negative out by saying it's I square roots of 48 minus I square roots of 27. And our goal is to look for perfect squares to break up 48 and 27. And 48 and 27, 48 breaks up to the square root of 16 times the square root of 3. And 27 breaks up as the square root of 9 times the square root of 3. And so you'll notice they both have a square root of 3 in common, and the other numbers can actually be square rooted. I'm going to bring this I down so we don't forget about it. But this first square root, this first quantity, ends up being 4I and a square root of 3. The 4 comes from the square root of 16, the I we have to keep with. And then we have a minus. And if I look at this, the square root of 9 is 3, so minus 3I square roots of 3. And when I work on this, I can just work with the numbers in front. 4I minus 3I is 1I with a square root of 3. Here's my final answer. Okay, those are the two easier ones. C, looks like my parentheses kind of got mixed up here. It should be a parentheses negative 1 plus the square root of negative 3 and then quantity squared. So we just want to make sure this looks all right. Squared means I'm going to FOIL. So I'm going to rewrite this just a minute. Negative 1, and I'm going to pull out my I here, plus I square roots of 3 times negative 1 plus I square roots of 3. Okay, and I'm going to FOIL this. Negative 1 times negative 1 is 1. Negative 1 times I square roots of 3 is negative I square roots of 3. I square roots of 3 times negative 1 is another negative I square roots of 3. And I square roots of 3 times I square roots of 3 is an I squared times the square root of 9, because I'd multiply these two together. Okay, now, I want to work with this guy a second. The square root of 9 is 3, and I squared is negative 1, so this is negative 3. And you'll notice I can combine these. Negative 1I and another negative 1I is a negative 2I square roots of 3. And then I have this 1 in front. So let's simplify finally. 1 and a negative 3 is negative 2 minus 2I square roots of 3. Okay, so we do have some FOIL in here with I's and square roots. Biggest thing though, don't forget your perfect squares, because we're going to be breaking apart square roots again. You're looking for numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and you can keep going. But those are the numbers that you're looking for. Like here we did 9 and 16. Those are the numbers you're looking for when you break apart square roots. Okay. Our last idea is to solve equations when you have I's in your answer. And so I'm going to slide this down. Okay, let's take a look. X squared plus 49. 49 is a perfect square, which is nice. You cannot factor this though because there's a plus and not a minus. So what I'm going to do is go through and solve. I'm going to subtract 49 on both sides. So x squared equals a negative 49. When you square root, don't forget you get two answers, plus and minus. The negative will tell me, basically, I have a negative square root of 1, and I have a square root of 49. The square root of 49 is 7. The square root of negative 1 is I, so I have plus or minus 7i. Okay, and you should start recognizing, too, what's going on with the negatives and the perfect squares and things like that. If 49 couldn't be easily square rooted, you would have to break it down with your perfect squares. Last one, because I'm telling you that it has a complex number, we're not going to factor it. Instead, we're going to use the quadratic formula. Okay. The quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. And we'll write it here for you just in case you need it. This is something, again, you have to know. We will not give you the quadratic formula. So let's take a look. A is 3, B is negative 2, and C is a positive 5. So I'm going to stick these in my formula. So x equals 2 plus or minus the square root, negative 2 squared. Why did I do parentheses? I want my calculator to do it correctly for me. Minus 4 times 3 times 5, all over 2 times 3. And we're going to do a little simplification from here. 2 plus or minus the square root. Now, negative 2 squared is 4. All of this is 60. So 4 minus 60 is negative 56. All over 6. Okay, we've got to do a little bit of work then. We're going to break apart 56. I know no matter what, I'm going to have an I because of this negative square underneath the square root. It's 56 I then have to break apart. 56, you want to look for one of those perfect squares. So we're looking for 4, 9, 16, 25, 36, so on and so forth. You always want the biggest one, so I start dividing 56 by 36. Do you get a whole number? No. 56 by 25, do you get a whole number? No. 56 by 16, do you get a whole number? No. 56 by 9, no. 56 by 4, yes. It ends up being the square root of 4 and the square root of 14. And the square root of 4 is just 2. So that 2 is going to go in front of the I, and then I'm left with this square root of 14 all over 6. And then, once you've simplified your square root, now you can divide by 6. And I need it in a plus bi form, so I'm going to divide these. 2 divided by 6 is 1/3, plus or minus. 2i divided by 6 is I square roots of 14 all over 3. And you could leave it here, or you could also say it this way if you want the I at the end, the square root of 14 over 3i. Either of these would be acceptable. It doesn't matter to me. Mathematically, you see the I in front of a square root more than you see the I at the end, but I would take either. Okay? Thanks for watching section 2.4. Again, don't forget circle star anything that you have questions on, but please make sure quadratic formula is something that you know.